National Electrical Code Section 250.94 addresses bonding requirements for service equipment. Specifically, it outlines situations where bonding bushings or grounding locknuts are required on metallic raceways and enclosures containing service entrance conductors. If the flexible conduit is not on the line side of the service, meaning it's downstream from the main service disconnect, Section 250.94 does not apply. In a specific scenario of a flexible conduit feeding a disconnect for a heat pump, this is typically considered to be on the load side of the service. Therefore, a bonding bushing or grounding locknut is generally not required by Section 250.94. However, it's important to consider other factors and relevant code sections to ensure proper grounding and bonding throughout the electrical system. Firstly, examine Section 250.4, which covers general requirements for grounding and bonding. This section emphasizes the need for effective ground fault current paths and minimizing voltage differences between metallic parts. Secondly, review Section 250.92 regarding bonding of metal enclosures containing service conductors. Although 250.94 might not apply directly, 250.92 provides guidance on bonding methods for service equipment. Thirdly, consider Section 250.96, which pertains to bonding other enclosures. This section may be relevant depending on the specific installation and whether the heat pump disconnect enclosure requires additional bonding. Fourthly, assess the specific requirements for equipment grounding conductors as outlined in Article 250. An equipment grounding conductor, often referred to as ground wire, is essential for providing a low impedance path for fault current back to the source. A number 6 aluminum conductor used as the equipment grounding conductor must comply with the ampacity requirements outlined in Table 310.15b16. Fifthly, flexible metal conduit installations require careful attention to grounding and bonding. Section 348.60 addresses the use of flexible metal conduit as an equipment grounding conductor. It states that flexible metal conduit can only be used as an equipment grounding conductor if specific conditions are met, including limitations on length and overcurrent protection. Sixthly, if the flexible metal conduit does not meet the requirements of 348.60, a separate equipment grounding conductor must be installed within the conduit. This separate conductor ensures a reliable ground fault current path. Seventhly, when using aluminum conductors for grounding, ensure proper terminations and connections. Aluminum is susceptible to oxidation, which can increase resistance at connections. Eighthly, use appropriate connectors and fittings listed for use with aluminum conductors, and apply an oxide-inhibiting compound to the conductor before making the connection. Ninthly, carefully inspect all connections to ensure they are tight and secure. Loose connections can lead to increased resistance and potential overheating. Tenthly, consult the heat pump manufacturer's instructions for specific grounding requirements. The manufacturer may specify additional bonding or grounding measures to ensure proper operation and safety. 11thly, consider the overall grounding system design and its impact on equipment performance and safety. A well-designed grounding system minimizes the risk of electrical shock and equipment damage. 12thly, check for any local amendments or requirements that may supersede or supplement the National Electrical Code. Local jurisdictions often have their own electrical codes and regulations. 13thly, understand the difference between grounding and bonding. Grounding connects the electrical system to the earth, while bonding connects metallic parts to create an electrically conductive path. 14thly, verify the integrity of the grounding electrode system, ensuring it is properly installed and maintained. The grounding electrode system provides a connection to earth for the electrical system. 15thly, perform regular inspections and testing of the grounding and bonding system to ensure its continued effectiveness. Testing can identify potential problems before they become safety hazards. 16thly, if there is any doubt about the proper grounding and bonding methods, consult with a qualified electrical engineer or inspector. Their expertise can help ensure a safe and compliant installation. 17thly, always prioritize safety when working with electrical systems. To energize circuits before working on them, and use appropriate personal protective equipment. 18thly, flexible metal conduit is commonly used for connecting equipment like heat pumps due to its flexibility and ease of installation. However, it is crucial to follow the code requirements for grounding and bonding to ensure safety. 19thly, when installing a heat pump, the disconnect switch provides a means of disconnecting power to the unit for servicing or maintenance. The disconnect must be readily accessible and properly rated for the heat pump's electrical characteristics. 20thly, the size of the conductors feeding the heat pump disconnect must be appropriate for the heat pump's ampacity rating. Refer to the manufacturer's specifications and the National Electrical Code for proper conductor sizing. 21st, the overcurrent protection for the heat pump circuit, such as a circuit breaker or fuses, must also be properly sized to protect the equipment and conductors. The overcurrent protection rating should be based on the heat pump's nameplate data. 22nd, the wiring methods used for the heat pump installation must comply with the National Electrical Code requirements. Common wiring methods include conduit, cable, and individual conductors and raceway. 23rd, the location of the heat pump disconnect must comply with the National Electrical Code and any local requirements. The disconnect must be readily accessible and located within sight of the heat pump. 24th, the type of enclosure used for the heat pump disconnect must be appropriate for the environment. For example, an outdoor disconnect may require a weatherproof enclosure. 25th, the grounding electrode conductor connects the equipment grounding system to the grounding electrode. The size of the grounding electrode conductor is based on the size of the service entrance conductors. 26th, the bonding jumper connects the equipment grounding system to the neutral conductor, the service equipment. The size of the bonding jumper is based on the size of the service entrance conductors. 27th, the supplemental grounding electrode provides an additional connection to earth. Supplemental grounding electrodes are often used in areas with poor soil conductivity. 28th, the use of ground rods, ground plates, and underground metallic water pipes as grounding electrodes must comply with the National Electrical Code requirements. Each type of grounding electrode has specific installation requirements. 29th, the resistance of the grounding electrode system should be as low as possible, ideally 25 ohms or less. A low resistance grounding system provides a more effective path for fault current. 30th, the National Electrical Code provides tables and guidelines for determining the proper size of grounding and bonding conductors. These tables take into account the ampacity of the circuit and the type of conductor material. 31st, the use of exothermic welding, also known as cadwalling, provides a permanent and reliable connection for grounding and bonding conductors. Exothermic welding creates a molecular bond between the conductors. 32nd, the use of listed and labeled grounding and bonding products ensures that they meet industry standards and safety requirements. Look for products that are certified by a recognized testing laboratory. 33rd, the proper installation of grounding and bonding systems is essential for electrical safety. Incorrectly installed grounding and bonding systems can create hazardous conditions. 34th, the maintenance of grounding and bonding systems is important to ensure their continued effectiveness. Regularly inspect connections and conductors for corrosion or damage. 35th, the National Electrical Code is updated every 3 years. Stay up to date on the latest code requirements to ensure compliance. 36th, the local electrical inspector is responsible for enforcing the National Electrical Code. Consult with the local electrical inspector for clarification on any code requirements. 37th, the electrical contractor is responsible for installing the electrical system in accordance with the National Electrical Code. Choose a qualified and licensed electrical contractor for your electrical work. 38th, the homeowner is ultimately responsible for ensuring that their electrical system is safe and compliant with the National Electrical Code. Educate yourself about electrical safety and maintenance. 39th, the National Electrical Code is a comprehensive set of rules and regulations for electrical installations. It is designed to protect people and property from electrical hazards. 40th, the proper application of the National Electrical Code requires a thorough understanding of electrical theory and practice. Seek out training and education to improve your knowledge of electrical systems. 41st, the use of flexible metal conduit in damp or wet locations requires special consideration. Use liquid-tight flexible metal conduit and fittings to prevent moisture from entering the conduit. 42nd, the support and securing of flexible metal conduit must comply with the National Electrical Code requirements. The conduit must be supported at intervals that prevent damage or strain. 43rd, the bending radius of flexible metal conduit must comply with the National Electrical Code requirements. The bending radius must be large enough to prevent damage to the conduit or conductors. 44th, the use of reducing washers and locknuts for connecting different sizes of conduit requires careful attention to grounding and bonding. Ensure that the reducing washers and locknuts are properly installed and provide a reliable electrical connection. 45th, the use of non-metallic conduit and fittings requires a separate equipment grounding conductor to be installed within the conduit. Non-metallic conduit does not provide a conductive path for fault current. 46. The identification of grounding and grounded conductors must comply with the National Electrical Code requirements. Grounding conductors are typically green or bare, while grounded conductors are typically white or grey. 47. The use of ground fault circuit interrupters, also known as GFCIs, provides additional protection against electrical shock. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. 48. The use of arc fault circuit interrupters, also known as FCIs, provides additional protection against electrical fires. FCIs are required in certain locations, such as bedrooms and living rooms. 49th, the use of surge protective devices, also known as SPD, protects electrical equipment from voltage surges. SPD are recommended for sensitive electronic equipment. 50th, the proper labeling of electrical panels and circuits is essential for safety and maintenance. Clearly label each circuit breaker or fuse with its corresponding load. Therefore, while National Electrical Code Section 250.94 may not explicitly mandate a bonding bushing or grounding locknut in this specific heat pump disconnect scenario, a comprehensive review of all relevant code sections and factors is essential to ensure safe and compliant installation, especially focusing on effective grounding and bonding practices.